Good day, everyone. We are from the group Big Brains, and today we are going to present our project 2, the concurrency problem. So the problem that we have received this time is deadlock, but we don't have the deadlock problem in the system of our project 1. Therefore, we are going to simulate the deadlock problem using Node.js. So we have created two databases, the database 1 and database 2, and we have two tasks. So the first task is going to save the data into the first database while reading the data from the second database, while the second task is going to save data into the second database while reading the data from the first database. Since each database is only accessible by one task at the same time, therefore, we might face the deadlock problem here. Okay, so now I'm going to run the program. Okay, so as you can see, the program starts here. So this task 2 is already using the database, and this task 1 is using the database. But the save success message is not displayed. This is because of the deadlock already happened.
Okay. Based on what we found from the research paper, we've come up with a solution to solve this deadlock problem, which is by using the Petri Net. So this is the Petri Net library that we found and we import to our project. Okay, so this is the Petri Net diagram. P stands for place. So here we have P1 and P2, which is place 1 and place 2, and T is transition. So here we have transition 1 and transition 2. So I start the simulation. So when T1 is fired, P1 will send the token to T1 and T1 will generate a new token to P2. And when T2 is fired, P2 will send the token to T2 and will generate a new token to P1. Okay, back to our code here. First of all, we initialize P1 and P2 here, and then we initialize the T1 and T2 here. So at here, we can see that P1 is the input place and P2 is the output place for T1. And for T2 over here, P2 is the input place and P1 is the input place. After that, we initialize the net by setting P1 as the starting point. Then we ingest the net with one token. Okay, so at here, every time the data is sent, T1 will fire. As you can see right here. So when T1 is fired, this is the event listener. It will proceed the task 1 right here, and then it will fire T2. So when the T2 is fired, this is the event listener for T2. When T2 is fired, the task 2 will be proceed, as you can see right here. Okay, after we implement our solution, so we try to run again. As you can see, the problem is solved. And you can see the save success here, which means that task 1 and task 2 is successfully run without deadlock occurring. So that's all from us. Thank you.